Hi, sir.
Yeah, morning. Good morning.
Good, sir. We are going to start the meeting.
Sure.
Good morning, all. The Society of Naval Architecture Students, SNAS, is a students' body by the students of Department of Ship Technology.
Okay.
It is responsible for nurturing students with things outside of books by conducting various events like this. Today, we have Commander S. Kumar, sir, Head of Design of Aviation, Hull System, and Equipments, including all aspects of integration, L&T Shipbuilding Defense. He is 12th batch alumnus of Department of Ship Technology. Now it's my honor to invite Commander S. Kumar, sir, to lead us to the webinar on topic the digital threat. Sir, please.
Yeah, thank you. I'll just share my screen.
Okay, sir.
You can just tell me if it is if my presentation is coming.
Yeah. Yes, sir. It's visible.
It's visible, no? Yeah.
Yeah.
Yeah. Okay. Good morning to all of you. It's a pleasure for me to actually give this, kind of talk as a part of the SNAS webinar series. For me, Cochin University, holds a lot of very good memories, and I know that I guess predominantly there may be the listeners would be from Cochin University and from students and all that. So that's very nice because by having these kind of webinars, you kind of get insight into what's happening in the real world, and that will be the best preparation for students who are passing out of the college. So without much delay, since a lot of people already joined, I think I'll get on with the topic which I'll be speaking about. Just before I do that, a very short background of myself. In fact, after passed out in 1992 January from Cochin University and then 2 years in IIT Delhi, I started my career in submarine refits in Vizag Dockyard from 1994 to 99, and then 2 more years in Admiralty Shipyard, St. Petersburg. Again, we had two of our submarines which were sent there for modernization and refit. So a lot of submarine work in my background, at least for the first 15 years. Just last 4-5 years, I was involved deeply in ships, and that too as command construction officer in based in Kochi. So when I passed out in 2013, I joined L&T, and since the time I joined, I've been heading the hull outfit, aviation, special systems, accommodation, and miscellaneous load handling systems in L&T. L&T, we have a pretty big design organization, so I'm heading a group, which is doing designs. We do basic design, we do detailed designs, everything, and we also give a lot of support for refits. So just a few pictures of what really influenced me. I wanted to mention is that especially I made a trip to Marin sometime after I joined L&T, and that had a lot of influence on me. The way they kind of collected data, the way they produced reports instantly. I was kind of amazed to see the kind of instrumentation and the kind of automation they had. So that is the time I started really thinking that we should spend a lot of time on digital things, because we all do the conventional shipbuilding in the normal way, and we need to really catch up with technologies which are changing rapidly. So that is the time I started spending some time on how we can do it. And since 2000, maybe 16, 15, 16, I started spending time on PLM. which is product lifecycle management systems. Although I was heading the design groups, but then I took a lot of initiative to implement these kind of things and to understand the power of using all these kind of systems. So this digital thread in shipbuilding nowadays, I mean, the topic itself, some people you'll hear it's called digital twin. A lot of people talk of digital twin, digital thread, but one thing common is it's all digital. So in this talk, more than our conventional shipbuilding, I'll mainly be focusing on the digital aspects a little bit more in detail than I hope you would have seen earlier. So I'll begin. So shipbuilding is a data challenge. And why shipbuilding is a data challenge? We got lakhs of systems. If you look at a component level, you have equipment, you have small components, you have spare parts, you have a system of systems, so many different navigation systems, electrical systems, weapon systems, fuel systems, freshwater systems. And then you have the hull structure, of course, which is kind of integrated with that. And of course, you have the main propulsion systems and maneuvering, so many things which are there. All these systems, a lot of data goes into its designing, its sourcing, manufacturing, its integration on board, its testing, its trials. I mean, you're on one hand, you have the physical component, that is, you have the physical items, the steel plates, the structures, and the equipment which kind of ships in and gets installed on board ships. But on the other hand, we have the digital part. For every equipment, there is a weight, there is a performance, there is a capacity, there is technical details, there are certain components which are there in that, there are certain parameters which are there in that. So that is a lot. And when you start kind of looking at it, as a whole, you'll find that each equipment, every system got different type of equipment, different type of parameters. So it's a very, very different type of data, very different formats. Some you have in DXF formats, like all nesting data you have in DXF formats. You got a lot of CAD data in STP, STL, and different formats. 3D model systems like in our L&T we have Cadmatic. It has got its own formats. I'm sure that other shipyards will have their own format. Maybe Tribond will have its own formats. So the big challenge is that you have a mix and match of a lot of these different formats. And then you do have in shipbuilding. Shipbuilding is not a small place where small kind of workshop things are done. Shipbuilding is wide. It's so many shops. It's got a wide geographical area. It's got building berths. It's got the berth where you will actually the launching after launching the floating berth. So practically, when you look at it, right from the drawing board to the design office till the time it goes to the shop, manufacturing, assembly, blocks, then building berth, and then finally the commissioning, the delivery of the ship. It covers a very wide span. So that means all these data, what we're talking about, all these systems, the data and the interrelationships, is something which we need to manage across this particular area. I just wanted to just check, Abdul, is my speed okay? Should I slow down? Is it okay?
It's okay, sir.
Yeah, it's okay. Great. So if there is some problem, please kindly let me know that. Yeah. So we have these wide formats, and on top of that, we have got technologies which are changing. Yesterday and today we say PLM. We're talking about IoT, which is Internet of Things, where we integrate a lot of live data from equipment and then analyze them. And when you do analysis nowadays, a lot of talk of AI and AI models, deep learning. So that is something which is happening actually on the ground, and people are already talking about the next level of technologies. So when you say the data, it is widespread, and you can see this in the slide. The bottom highlighted portions are what are the challenges? The challenge is it is always cumbersome to exchange data between different softwares. Between softwares normally which are designed and which are made to integrate, like for example, when you say CAD and PLM, you may have, let's say, if you have CATIA as a CAD software and Enovia, your PLM, they are integratable because they are already designed like that. Similarly, you may have some other softwares which are already designed to be integrated. So that there's no challenge at all. But then the moment you have to integrate softwares which are having information of some equipment or ships or 3D model across different software makers, that's where challenges come. On top of that, you've got stringent data security policies. Almost all shipyards in India, we deal with defense ships. We deal with data which is restricted, confidential. So that means there are restrictions of putting things on cloud and all those things. So we need to manage all these on premise, that is within our own shipyard, through our own networks, through very secure networks. Then when you're talking about data, see, the thing is, a lot of our data, lot of when I say data, I'm talking about the past data or data of previous ships, previous designs, and from a lot of our reference material, research papers, a lot of our curves, they're all legacy data. So when I mean legacy, means they're all data which are maybe created, generated 15, 20, 30 years back, but they're still useful now. How do you kind of integrate with them? How do you kind of access them? So this is certainly not an easy challenge, and something which probably still work is going on. Different shipbuilders, different customers, everybody wants to have data on their own way. There is no standard. There is no clear-cut kind of guideline or standard that this is what we found when we said data management. I'm not even going to digital thread. I'm just trying to tell that there are so many customers and so many shipbuilders. Everyone have got a different definition of the same thing, what they have and what they want from a digital system. Many activities are manual. Many are not kind of always, have a software for everything. In shipbuilding, a lot of manual work also goes on. How do you kind of get that? But they may be crucial work. From a data point, they may be important. So how do you get that on board? So this is where we stand with respect to data challenge, which we face in shipbuilding. So I've used this term digital threat. Some people, as I've said before, they use digitalization, digital twin, so many different terminologies. But for me, what's important is, why do you want a digital threat? What's the main takeoff from that? The first thing is, you need to have efficient connectivity between different softwares and hardwares, and interfaces will minimize effort. You don't want to have a situation where you have one software, you will download a lot of data from an Excel file. That is actually a manual process, although the data will be in an Excel file. And then from that Excel file, you will again have to upload it to some other software. So that is not very efficient in terms of connectivity. You can do a lot better job by just integrating these two softwares. It can be between any two softwares. It can be between a PLM and CAD. It can be between an ERP and PLM, between anything, any two software. Next is replication of data. You don't want to have errors. Every time you start creating data manually. Of course, it is man who creates data. So to that extent, if the data itself is created incorrectly, nothing can be done. It's garbage in, garbage out. But on one hand, if the data is already created, in the process of replication, in the process of duplicating it, that could be errors, which can be very, very costly in a running project. So that is something we need to avoid. For example, you may have a list of compartments, which is used in many places when we do shipbuilding. But that list of compartments, if it is kind of created by 2-3 different people, then there is a chance that the update will not happen. There may be some change in the general arrangement, some change in the compartments, and that information will not go downstream, and that will result in errors. So whenever you're doing these kind of connectivity or digital threads, it's very, very important. That you use the technology of integration to have only one owner and one source of data. There should not be multiple sources. There should be one source. You can always have different people for different sources, but for one data, there should only be one source. That's how the data management needs to be done. You also are looking for a kind of backbone, a data bus, I would say, a kind of backbone where you don't know what all is going to come next, what all type of technologies, what all requirements, maybe IETP, interactive manuals, Tomorrow, the customers will start saying, "I want digital twin. I want something. I want to connect to my ships, which are in the fleet." So if those kind of requirements come, you should be in a position where you're 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 having the infrastructure to kind of absorb it. So that's why it's important that you have a predefined digital thread with various elements, which I'm going to explain a little bit more in detail in subsequent slides, in which you can entrench further data, future kinds of data. But I have written here, it needs executive focus, because in any enterprise or any organization which is going to embark on this kind of exercise, it's definitely going to be wide ranging. It's going to take time, it's going to take resources, and that's why it needs a lot of executive support and focus. So this is a kind of pictorial or very clear definition of what I've been saying regarding digital thread. So you always begin with something here, which is requirements. In any project, you have the customer who will spell out requirements, which will be telling that, okay, this is the job to be done, this is the weight, this is the displacement, this is the speed to be achieved, this is the equipment which I want on board, these are the capabilities, this is the performance I need, these are the specifications, these are the standards we followed. There are so many. Even for a single project, you'll have many different requirements and specifications. So obviously, you have got to have a requirement management or requirements engineering system. Now, normally you do have dedicated requirements engineering systems like Doors is quite popular, Doors from IBM. But you do have requirements management also built in within various PLM softwares nowadays. So as I mentioned before, you'll keep hearing this word PLM from a product lifecycle management software, because I consider that the PLM would be the backbone. The PLM is going to be the backbone in which all others will have to connect. PLM can get data, PLM can generate data, PLM can distribute data, but that will be the backbone. So requirements by the customer are, I would say that in a digital scenario or in a digital thread, we need to not only monitor the compliance of our design and of our building and of our ship, whatever delivered ship, to all the requirements and standards, but we also need to show the proof of the compliance. So that's why all these requirements are managed on a line-to-line basis and kind of mapped to the PLM system, because it is a PLM system in a typical digital thread scenario, which will have the main data of the ship, like, for example, its product structure, its systems, its various equipment, its components, and a lot of data on these equipment and systems. Obviously, the 3D model is the centerpiece. This is where the physical ship is actually modeled before in the design stage, and obviously the 3D model and the PLM, that has to be in a digital thread, two-way integration. I will explain in a subsequent slide a little bit more on kind of visualize how exactly this kind of integration is done. Just to talk of other, so I also forgot to mention that in a PLM system, other than the product structure and the bill of materials, that is the form, you will have system architectures which are built in, which means a lot of all the systems are all having their own component level. So kind of, how do you know that a system and its components which you are envisage will meet the performance requirements? So that is where system engineering plays a big part. Some people call it MBSE or model-based systems engineering. So model-based systems engineering, also there are kind of dedicated, I would say, applications which are there. And some of these PLM systems are very closely, they need to be integrated with these model tools. I will show some kind of a model-based design tool just to give a feel of what exactly happens and how and what goes into a PLM system. Change management is very well known. Change management is also generally managed in a PLM. They got a workflow. Whenever there is a change, which is required either from the customer or from the production saying that something is wrong with the design, or the designers themselves, you create change objects. And these change objects go through a workflow where they are authorized, the costing is done, technical feasibility is studied, and then finally the change is approved, and the system takes care of the revision of all the deliverables which are related to it, all the drawings, all the models. It's not a very simple thing. When you have got a very complex system of systems where you got a lot of interrelationships between various parts, it's very challenging, I would say, to manage without these kind of systems. So that's where I would say efficiency of data management comes into play. So this is the physical product, as I've said before, although I'm showing a kind of a shop floor here, but just to demonstrate that a lot of, like even in our shipbuilding scenario, we have got cutting machines and we have so many other machines. We'll have a lot of parameters which are there, which are kind of required for operations in these machines. So that definitely there could be cases where such information also needs to come back to the PLM and kind of viewed as a part of the digital thread. So there is one more thing that even when you talk of the ship after delivery, we talk of operations of the ship, maintenance of the ship, modifications done on the ship. That's where, again, digital thread, you'll have all these things as a part of the overall connected system. Yeah, I'm not trying to suggest that it can't be done without a digital thread. I'm just trying to suggest that with a digital thread, life is much more simpler. You can be much more efficient, and you can retrieve data a lot faster. So just wanted to highlight that part. So that is one aspect. The one aspect I wanted to also mention here is content generators. Now, PLM also has got facility. I have a slide for that. I specifically want to mention about content generators because a lot of documents, inspection document, trial documents, testing documents, system description, operating manuals. Many of these documents come from the OEM. Many of the documents, we have to integrate our information which we use during construction and design, so that we had to kind of create composite documents. So it's always a good idea to have, to the extent possible, all these documents generated through existing data. After all, if you really analyze data, if you really analyze today installation or let's say an operational manual of a certain equipment or a system, actually you'll see that almost all the data which is required for that are already there in different places. Some of them design data, some of them from construction, some of them from the equipment owner, OEM. So if you have done a good job of connecting all this already in your digital thread, then you use this facility of content generators and start generating trial protocols and all these installation documents for big ships and for shipyards where there are multiple projects where you're kind of really pressed for resources. These things would become very useful. This is, I was just mentioning to you about a CAD PLM integration. To a normal shipbuilding scenario, CAD PLM is, talked of in the same breath. But then for a lot of youngsters who are listening, this is something which needs to be. I think it's quite important to understand that this sort of integration is important to appreciate. So here you have a system where, of course, I've chosen an example of ARAS PLM, which is just as a demonstrator, and a Cadmatic 3D model. So you can see how, in CAD, in the 3D model, you've got certain data which is there. For example, the equipment position ID and some other IDs which are specific to the CAD. That goes to PLM. And in PLM, a lot of the data, for example, you've got some weight data and some other data. You've got, like, for example, capacity data. Like here you can see capacity and some data from the OEM part number. All that data, actually, I don't you don't need to put it in CAD. You're putting it in PLM, and that translates back to the CAD. So when you're extracting drawings, when extracting information or BOM from CAD, so that time these kind of data from the OEM is already there. So that's what I wanted to convey. And how it is done, it all depends from software to software. But in this particular case, you've got model queries, which are built-in features, which are built into Cadmatic. And when you got APIs, like you must have seen this in my presentation already. REST API, they are all application program interfaces. They are kind of phone calls which you make from one system to another system. And when you make that phone call, you can ask for certain data that will give you that data, and you can even push data. So precisely that principle is what is used here in this close integration, two-way integration, which you can see from the PLM to the CAD and from CAD to PLM. This is just a very small example. I've given a few parameters, but when you start looking at the whole spectrum of information which will be needing to be shared between an OEM and between PLM and a CAD model and vice versa, it's massive. It's quite big. Yeah, here I was talking about integration of PLM with MBD, or a model-based design tool. I did talk about model-based systems engineering, which is actually a more advanced kind of framework where you can do real proper systems design. Normally in a system design, you have requirements, you have the system components which will make up the system architecture, and then you run the simulation, and then you have the output, you have the performance, and the performance is matched against the requirements. So if the requirements are met, then the system is okay. If it is not met, then the system design is tweaked, and all this is done in a system MBAC, that is a model-based system engineering application. In this particular case, you got, for example, I'm not sure whether it's visible, but here you have got equipment number, for example, which is the main basis for selection of anchors and mooring equipment and everything, towing equipment. So anchoring. So you have this equipment number model, which is basically comprising from based on class rules and from very basic ship parameters like length, displacement, etc. And when you run that particular simulation, what happens is that the results of these simulation, like you can see the steps here. You have the input script, you have the component model, then you have the simulation, and then the output. This output, when it runs in this simulation, that is in this case, it's a Scilab. Scilab is a model-based design tool. So when you run it in Scilab, it kind of it's got a capacity to send this information to IoT applications, a few certain IoT applications. In this case, it's UBI dots. I think I've not mentioned it anywhere, but it can be any IoT. There are various IoT applications. So what you see here is IoT. So you can see that when a simulation is run here, the design model in which you get certain parameters like speed and draft and so many other things, that goes to the IoT software, and IoT is integrated with PLM. So even if you don't have a direct connectivity between a PLM and between the design model, if you have got the connectivity between PLM and IoT as a design model, that is good enough. So you can have direct connectivity, you can have indirect connectivity. That's why I call it a thread. It is not always a direct connectivity. It can even be second level or a third level connectivity. I'm sorry that this slide is not that clear, but then I just included this in the last minute. I couldn't get a clearer version. But I just hope that the broad idea is understood. So this, I was mentioning on content generation. What I wanted to just mention about content generation, a very, very powerful tool, which we have to use in a digital thread scenario. On the left-hand side, we got certain scripts or codes which are normally provided in the PLM softwares, because the moment you start coding in PLM, you got access to all modules of PLM. Typically in a PLM, you will have requirements module, you'll have a project management module, you'll have a product engineering module, you'll have a quality management module, things like FMEA and all that. You will have change management modules. Then you will have a lot of technical documentation, process management, so many things. So the best part is when you do coding within PLM, you straight away have got access to all the other modules. That's why I was mentioning in the beginning that it's always a good idea to have PLM as a background for the digital thread and integrate all the other outside information. This document, what you're seeing on the right hand side, I wanted to mention to you that you actually see this is actually a list of compartments, and this is the items which are there in a wardroom of a compartment. Actually, you're just seeing a small portion of it, but you're seeing various items like LED TV, home theater system, bar stool, and the figures of that. So like this way, you can imagine there are 400 compartments. Each compartment will have 30 to 40 items. So it is not practically efficient to manually create all this. So in this particular case, I wanted to mention that this entire thing has been, it's a result of content generation using data from the product structure, data from some other places. So this is just a small example of that, and you can see how this can be extended to various other documents also. I was mentioning to you regarding generating operational documentation, delivery documentation, compartment lists, and so many other things which a ship crew would like to have while taking over. So content generators are very can be utilized very effectively. Yeah. So this I actually took this picture from a paper that is study on PLM and big data collection for digital transformation of the shipbuilding industry by Sangil Park and Jun Ho, who published in the Journal of Marine Science and Engineering, 2022. I like this slide because it kind of showed the overall, shipbuilding in a single slide with perspective of operations. What this slide envisages is to kind of create a big data hub. Nowadays, we talk of deep learning and data models and how you'll use that for classification and for object detection and for so many other things. So on one hand, we have a lot of data which is kind of collected from the production shop floor, from the stores, from quality department, and from various such sources, logistics. Then we have a lot of this data of the operations, like you got the fuel, engine power, and speeds, a lot of information, fuel consumptions, the shafting powers, and so many other things which are generated during design. But then a lot of equipment data is also relevant for that. And what this shows is how all this data is kind of collected using data agents. Okay, it is just kind of demonstrating how data is connected from different places and passed on to a kind of a big data hub where you collect the data, you extract it, and then you index it, annotate it. You have got a lot of data required for training, and then for testing, and then for deployment of the model. And of course, I'd like to mention that from whatever I know, all these deployments, especially models which are requiring higher GPUs, require cloud infrastructure. Normally that is the case. So that is sometimes that becomes an impediment for our scenarios where we only want an on-premise network, which means not connected with cloud, which is only connected to within the organization. So I guess there will be options for that also. But the slide is just kind of shown to see the vast nature of our data. You can see that. So now, in fact, I have my presentation itself is not that long, but it was meant to be more of a kind of window to what is current and what we can see in the future. So what I see is like PLM itself, that is product lifecycle itself. You need to have capabilities to match technologies which are new technologies which are coming up. So PLM itself is adding to a lot of its own. It has also evolved over the last 10, 20 years. Initially, it was a desktop, then kind of desktop software, and then later on, it made kind of made into a web-based software, web-based access, and now recently, last 3, 4 years, you have seen cloud PLMs, PLM on rent. So you've got various options which people can exercise for using PLM systems. Of course, systems itself, integrated bridge system, platform integrated management systems, so many systems or integrated platform management systems, so many systems, other navigation systems are all having embedded software, embedded hardware, and integration across with different kind of control softwares. And that's what is happening. A lot of new devices are coming up. A lot of independent vessels are coming up. Like nowadays, you've got ships which are having capabilities for USVs, for launching their own USVs, which in itself are small ships, small warships of their own. They have got their own sonars and their own ASW equipment, anti-submarine warfare equipment, and torpedoes and all that. So there's no limit to the complexity of systems. A lot of systems embedded and with software. So that's why you're going to hear these words a lot: interfacing and integration. AI, everybody's talking about AI. Everybody's talking about generative AI, and we keep talking about predictive maintenance, preventive maintenance, failure prevention. All this is they're all the AI world where we use a lot of data for training, for testing, and so this is something which is taking the world by storm, especially generative AI. How it is going to impact our digital thread, especially with context to shipbuilding, is something which we'll need to see in the days to come. Ships themselves, a lot of focus on autonomous ships, unmanned ships. A lot of work is going on. A lot of shipyards are kind of looking very having their own projects for this, because they see a lot of potential in these ships. And of course, in the commercial world, green ships are certainly the most important focus right now. So in this scenario, all this is going to have an impact on how and what systems, what softwares, what hardwares are going to come. I already mentioned about MBSC, IoT, and of course ML. These are rapidly changing technologies. We don't know what form it is going to take, but then whatever digital thread we are envisaging has to factor all these into account. So what are the challenges to digital thread? Which are I would say clear and present challenges. Digital thread to what? Is it digital twin to what? What next? See, first thing is there are a lot of questions on ROI. What is the return of investment? Who's asking for these kind of things? Is any customer asking for this, or as a shipyard, as a shipbuilder, am I going to do it on myself? That is something which is a ROI kind of a problem, and you need to kind of see what are the returns for the investment which you make, and accordingly chart out the course. Of course, customer expectations are always rising, and they are bound to go into this area. They may be looking towards having a kind of standard, because they are having big fleets now. If you look at our own, the Navy, probably it has got over 150, 160 odd ships, and it may have different expectations on how to move ahead in the future. So that is something which all shipyards will need to factor. And then I think definitely there has to be some focus on research and development. Like, for example, how do you, in a typical scenario where you're already into a lot of current projects and already into a lot of work, it's not so easy to keep changing, keep looking at new things, implementing it, and then just going full steam on that, unless you have a very focused approach on R&D. So this is something which is a point for all organizations. How we'll be able to deal with this influx, rapidly changing technologies and rapidly changing expectation of customers, something which we'll have to see. Of course, on the other hand, you've got rising computational performance requirements and infrastructure. Nowadays, you make computers, it's getting it's getting old very, very quickly, and it's not able to keep up with the computational performance and requirements, and you're having to go into more powerful systems with great processing power, and that is also increasing to the yard infrastructure and to the costs. On top of that, you've got this ESG sustainability standards by which all companies and all organizations are monitored, and you have to keep that into focus because it is these kind of standards which will actually have a big impact on the priorities, the operational priorities of a certain organization. Uh, I just wanted to again highlight why I'm talking about the organization, because the digital thread is not going to come by itself. The digital thread has to come from the organization. And that's why I was highlighting all the factors which are playing around our organization and what we need to kind of keep a tab on. Then we have, of course, the human elements, skills and expertise. I was just reading the other day, I think somewhere in the paper about maybe about little about 2 weeks back. That paper, that article was mentioning what level of people or students or they know coding. I'm not very sure. I think it's what level. It is just that it is a figure of what level of population is aware of coding. So I think in Tamil Nadu and Kerala it was probably highest. It was around 6%, and that was the highest. So you can imagine it is from 6% down to 5, 4, 3, and some places it was point something, point not percent. So this is something which is something which needs to catch the eye. We are entering to an age where, if you ask me personally, it's always good to have coding experience. We are so that you can keep in touch with what's happening in AI, what is happening in machine learning and so many other things, and you'll be in a much, much better position to play a very, very active role. Yeah.
Sir, are you presenting?
Yeah, I'm presenting. Are you
Sir, we can't see.
Oh, I said. Yeah. I'll do it. Sorry.
Yeah.
Just a minute.
Yes, sir.
Since when did you not? When did you miss my feed?
Like 5 minutes or so.
Oh, 5 minutes only. Okay. Just a minute. I think the sharing would have been lost. Yeah. The screen share.
Okay,
Yeah,
sir.
yeah. I'll just quickly go through the slides. I think
Yes.
I was. Did you see all these?
No, sir. The slide before this was.
Even this you didn't see?
No.
Oh my God! I think. Okay, no problem. This you must have seen, right?
Yes.
Yeah. So this is just, I'll run through it because I already talked about it. This is just integration between the design tool, that is model-based design tool, and the PLM system. But it is through an IoT, which is in this case it's UBI dots. But then I just wanted to demonstrate that you don't have to have direct integration between two softwares. You can always integrate through a third software. So in a digital thread, it's always connectivity, whether it is in the second level or whether it's in the third level. So I'll just move to the next slide because I think I talked about it, but I guess, I'm sorry that missed out this. So this slide is what I talked about content generation, where I said that, these content generators are very powerful tools which are there in any PLM system to generate documentation, which are required, like operational documentation, delivery documentation. So the document you can see on the right-hand side is completely generated using content generators. It is not at all, not a single portion of that is actually typed by hand. So when you look at the scope of content generators, when you look at the wide-ranging documents you need to generate, there is a strong case of seeing how we can use content generators. All these I'm explaining as a part of the digital thread because after all, we are talking about how we can digitize all the work we are doing, all the deliverables that are required by others, especially customers. This is the slide where I was talking about the paper which I referred, which was published in the Journal of Marine Science and Engineering, where we had the whole stock of production and stores and all assembly information, which are collected through various data agents. I mean, at least this paper talks about data agents for collecting all this information from different sources and also from the ship operations. Like you have the power and you have the RPMs and fuel consumptions, shaft powers, and so many things, ship speed, etc., into a big data hub. So in the big data hub, this paper envisages that the data will be collected, extracted, analyzed, and then you can actually train and test a model which will be deployed, so that this can be utilized by different people who need it, especially customers. So just wanted to mention that at least this gives the wide expanse of what I've been talking about with respect to a digital thread. See, I'm just rushing through these 2-3 slides because I already explained about it, but unfortunately the slides are not there, which I'm repeating now. Yeah, can I move to the next slide? Please, sir.
Yes.
Yeah.
Yes, sir.
Okay. Yeah. So this is where I was talking about the challenges with respect to, or the way ahead with respect to all these technologies, where technologies are rapidly changing. You have a lot of embedded systems and software. So you're going to hear a lot of these words like interfaces and integration, different softwares. You've got IPMS, integrated bridge systems, integrated platform management systems, a lot of equipment, USV control systems, torpedo fire control systems. So with all those complex systems which are there on board, you're going to have, again, how to extract data from that, how to integrate those kind of data into your PLM, thread, into your digital thread is going to be a challenge. And on top of that, you've got the AI world, you've got predictive, preventive maintenance. You have ships which are going to go green, autonomous, unmanned ships. The ships itself are changing. And you have this MBSE. I told you about model-based systems engineering, IoT technologies which are changing. And, the challenges from a company perspective, like the yellow text is what we are, our yellow background is what we have as challenges. Like companies have to deal with customer expectations. What is the return of investment? Before you go full stream into all these, what is the ROI with respect to all these? Who's going to do research and development? Because it's not going to come without some kind of an R&D. You got to have some kind of a dedicated R&D system or R&D people who can guide the implementation of all this. And then you have rising computational performance. You've got cloud, GPUs, and infrastructure which has to map up the hardware, and the software has to be in sync with each other. And organizations subjected to ESG sustainability goals, where they are monitored on all these aspects also. So all these are things which organizations who are implementing digital technologies will need to consider. That's why I put it in the slide. Finally, you have the human element, human skills. I was just mentioning some time back that the coding knowledge is only about 6%, and that too in Kerala, Tamil Nadu, and I think other states are a little lower than that. Something which I think really needs to catch the eye, and we need to see how to assimilate these technologies, how to develop expertise in all these. Because without all these knowledge, it's after all humans who are going to execute all these. It's not going to be softwares who do things on their own. So that is something which youngsters, and especially the college-going folks who are most of them who are in this presentation are all from that background, can really see how to build up your skills. So you'll be in touch with PLM technologies and also AI and machine learning and all that. So I think I guess I've come to a conclusion of what I wanted to speak about. I didn't have too many slides, but I just wanted to give an essence, kind of flavor of what we mean by digital thread or a digital twin, and how complex ships and complex requirements are going to kind of guide the current and the future projects. So Atul, that's it with regard to my presentation. So if there are any questions or I'll definitely try to address this. Yeah, can I stop sharing?
Yes, sir.
Yeah.
Good morning, sir.
Yeah. Yeah. Morning.
I'm Krishna Kumar, sir, batch 47.
Yeah.
Sir,
Krishna. Yeah, tell me.
I have one questions about the data collection, sir.
Yeah.
Some of the shipyard has their own design, like Albody, I can say Albody has their own design called Demon design. Will they will be able to share their data of design part to a common platform? So it will affect their own USP. That's a USP point of Demon. So data collection point of view, it's a huge problem. It will be a huge problem. There won't be any common platform where all the data can be collected.
Yeah, that's right. See, that's why I was mentioning that organization plays a very important role in creating this digital thread. If you have control of the information, then you can control how it can be manipulated, how it can be presented, and how it can be generated. So you're right in pointing out that if you have got a basic design from somebody else, then that is again going to be a lot of challenges until that is put into the contract, until a customer needs that this kind of data is required. So yes, I can say that organizations which do basic design and detailed design, like of course, there are many all shipyards have those capabilities. Those people who have got full control of the data will be much more successful in creating these kind of digital threads. So yes, there are challenges, and companies, especially foreign shipyards, Daemon and all that, nobody's going to part with their data so easily unless they're costed for that and they are agreeable to share that data.
Sir, I have another questions. Furthermore, that it's about sir, the error in this whole digitalization process. There are like human factor is there, digital waste is there, and then there is some we need some server to collect data, and that will become expensive as well. So return of investment part will be there. So what is the future expectation of this digitalization in shipbuilding, especially future expectation? Can we see?
Yeah. See, let me just tell you one thing. When it comes to expectations, there is no upper limit. Expectations are rising. Let me tell you, expectations from customers, from all customers, on all shipyards are rising. That too with the the emerging technologies like AI and all that. Everybody is now already asking, tell me what kind of AI applications are you doing it? What can you do with that for my ship? What digital twin can you create for my ships? Those kind of expectations are definitely rising. And I'd strongly advise that it's very important that shipbuilders and everyone looks at this very seriously in a very focused way and give that importance to that. There's no doubt that this is only going to increase. So we need to be prepared to change for it, and we need to prepare to adapt to these new technologies.
Thank you, sir.
Hello, sir. Good morning. I'm Ashish from 47th batch.
Yeah, morning, Ashish.
Sir, my doubt is, I've noticed you are from the Defense Department of L&T. So it's related to defense. How safe is digitalization in regards to defense? Because defense will have to keep so many secret information, and how safe is the information? Because digitalization is basically we are all uploading all our data into a digital database. So how safe is it?
That's right.
In perspective from a defense part.
Correct. So obviously, because it's a defense project, obviously there's no way in which we can, first of all, connect to the internet. Okay, which means cloud is out. So unless there are technologies and which at a corporate level they are they are bought into that and they've agreed for a corporate level implementation of all those things. As of now, all our implementations are on premise. That's why I use the word on premise a couple of times in my presentation. When I say on-premise means it's within the shipyard local network. There is no connectivity outside. So as long as we are sharing all this within the network, it's okay. But when it comes to a customer, it is possible that between the customer and between a shipyard, that could be a dedicated secure network. It's possible. So maybe that is an option which customers may exercise. So, but I don't know, and I am not, frankly, very sure about when we will be opening to a secure cloud framework. So that is something which I am not sure. But yes, the concern which you are raising is correct. When it comes to defense, we have to be ultra careful about sharing information. Certainly not to the net.
Okay, thank you, sir.
Yeah, is there any other questions? Abdul?
There is no more questions.
Okay.
So, sir, thank you for the insightful presentation, sir.
Yeah.
Comes to an end to the session. Now, I request everyone to have a look at the chat box and please fill up the feedback form provided there. Our Q&A session ended. Now, concluding, we would like to present a certificate of gratitude to Commander S. Srikumar sir for honoring this event and delivering such a wonderful talk.
Yeah. Oh, thank you. I didn't know there's such a certificate, but yeah, thank you so much for this opportunity. It was quite good for me to share my views with all these young students, and let's hope that all you youngsters will take these kind of things forward much better than what we have taken until now. So thank you so much for that. Abdul, thank you personally for being in touch with me and coordinating all these.
Yes, sir. It's our pleasure, sir.
Yeah. Okay. Thank you so much. Can I disconnect now or?
Sir, I have a small out of time session. So after
sure.
So I hope you all have enjoyed the webinar. On behalf of SNAS, I would like to express my sincere gratitude to Commander S. Srikumar sir for taking time from his valuable schedule and making this a very informative webinar in an interesting topic. My sincere gratitude to all members of those stars from all over the world for the exceptional commitment to the department. On this occasion, I would like to thank Professor Sadish Babu PK, HOD, for being a constant inspiration and for being with us in all activities conducted by SNAS. Last but not the least, I would like to thank every faculties and students who have put a sincere effort to attend the webinar and make it a grand success. Always feel free to contact us for the feedback. It's highly appreciated. Our webinar have been concluded. Now you may leave the meeting. Thank you.
Thank you.
Thank you, sir.
Yeah, bye.
Yes.